Audio Jungle. Audio Jungle.
Hello friends, my name is Samir Dokadiya and today I will discuss about the mechanism of cyclic ketone in Beckmann rearrangement, and I will discuss some examples. So let's start the video. So first of all, I am taking cyclic ketone. Cyclic ketone. So it reacts with hydroxylamine. You will get cyclic ketoxide. Okay, ketoxide. Then what happened? After this, Beckmann rearrangement start. Okay, in the presence of H plus or H plus of PCl5, etc. You can take anything. Okay, I am taking H plus so that I can do mechanism. Okay, so oxonium ion will remain. Okay, so this oxonium ion will remove. Okay, so this anti-position of oxonium ion is this. Okay, so this bond will migrate to the nitrogen. Okay, like this, and double bond C, and double bond C, and double bond C. Okay, it breaks this bond, breaks. So what happened? I am removing this. Okay, and this bond will migrate to the nitrogen. Okay, so I am writing here. Okay, after this bond, we should write it like this, and after the carbon we should write this bond. Okay, 1 and 2, 1 and 2. Okay, so after this, remaining 3 bonds, 1, 2 and 3. Okay, so I am writing like this. Okay, 7 member ring. Okay, so here the bond breaks, so this carbon will get positive charge. Okay, because this carbon, this bond will migrate to the nitrogen by taking both the electrons, so carbon will get positive charge. Okay, here. So after this we should write H2O to work up. Okay, for work up. So it have non-bonding electrons, gives its electron to the positive charge carbon. Here double bond. Okay, here positive charge generate on the oxygen. To remove the positive charge, hydrogen will remove in the form of H plus. Okay, so we have got catalyst. Okay, at the end of the reaction, like this H plus, then we will get so what happened after this. Okay, here you can see that this hydrogen will go to the nitrogen, and this double bond will migrate to this CO. Okay, CO. How? Like this. This bond is migrate here. and this bond will migrate to the hydrogen. For the simplicity, you can understand that this bond will migrate to the nitrogen first of all. Okay, like this. Here, this bond will migrate to the nitrogen. Nitrogen will get both of electron and negative charge, and it gives it electron to the H plus, because here you can see that this bond, okay, this bond will come here to make this double bond O. So this H plus will remove. Okay, so this H plus will come to this negatively charged nitrogen and make the bond with it. Okay, so we will get, I am writing here, okay, and NH. This is the product. Okay, the Beckmann rearrangement. You can have see that this negative charge carbon make the bond with H plus, and this bond will migrate to the carbon and C double bond O. So this is the all over the mechanism of cyclic ketone in Beckmann rearrangement. Okay, so before going to the examples, I want to give you the information. In Beckmann rearrangement, we know the migratory aptitude. Okay, we know that if leading group remove, so the migratory aptitude is not case, because in stereochemistry, anti-group will migrate. Okay, sorry, leading group will migrate. Okay, so the anti-position of leading group OH will remove, and its anti-position is this. Okay, so this bond will migrate. But when stereochemistry is not given, so we should know the migratory aptitude. So in Beckmann rearrangement, you should know that some says that migratory aptitude is similar. Okay, in both the reaction and rearrangement. Okay, very similar. First phenyl, then alkyl, and then hydrogen. In sub rearrangement, hydrogen, phenyl, and then alkyl. Okay, this is not a case. This is a migratory aptitude is determined by the experiments. Okay, so in Beckmann rearrangement, experiment says that first aryl group will migrate. Okay, if you use alkyl aryl ketone, so aryl group will migrate first, then the alkyl. Okay, so first aryl group, then alkyl group. Okay, then hydrogen. For hydrogen will not migrate. Okay, we can see some case. In some case it will migrate. Okay, so hydrogen is not a case for us. Okay, we should use aryl and alkyl, because alkyl seldomly migrate. Okay, so what is the order of it? First aryl group, and then alkyl group. Okay, in aryl we understand that first electron donating group, then phenyl. Okay, if electron donating group attach with this phenyl, so first this electron donating group will migrate, then phenyl, and then electron withdrawing group which attach with the phenyl group. Okay, in alkyl, first tertiary, then secondary, then primary, and then CH3. Okay, and write it here, CH3. This is the migratory aptitude. For the Beckmann rearrangement, we use both of these. We understand that first aryl group will migrate, then alkyl. So you can understand that hydrogen, for hydrogen, if we use hydrogen, so we can't predict anything about it, because hydrogen will be in the aldoxan. So aldoxan will give nitrile like this. Okay, this is aldoxan and this is hydrogen and phenyl. Okay, if you want to know the migratory aptitude of hydrogen, so if hydrogen is present here, it will be the aldehyde, okay, because two alkyl or phenyl or anything will give us octane, but one phenyl or one hydrogen will give us aldoxane, okay. So aldoxane will always generally give us nitrite. Sometimes in some case it will gives us the product substituted amide, okay, in some time, but generally we will get nitrite. So for migratory aptitude, if stereochemistry is not given, remember, so we should understand and we should know the migratory aptitude, that first allyl group will migrate, then alkyl group will migrate, okay. So first aryl, then alkyl, okay. First in the aryl, first electron withdrawing group attached with the phenyl group, then phenyl group, then electron withdrawing group, then in alkyl group first tertiary, then secondary, then primary, and then methyl. So let's start. First of all, we should understand that what is stereospecificity. In the last video I have not given the definition, but in this case we should know the stereospecificity. What is stereospecificity? Stereospecificity is the definition, is the stereochemistry of the reactant determining the stereochemistry of the product. How? Here you can see, and in the last video I have already told you that which group will migrate. OH group is the leaving group, okay, when H plus is connected with it and H2O will remove. So the anti to the leaving group is phenyl, so the phenyl group will migrate to the nitrogen. So here you can see the stereochemistry of the entire reactant is anti, okay. So this anti to the anti position of OH is phenyl, so this group will migrate. So this reaction is very highly stereospecific because it determines the stereochemistry of the product, okay. So this is the stereospecificity and its definition, okay. Let's start the examples. First example is very similar. I am taking here CH3, okay. This is the first example, okay. So this is ketoxane. What happened? If you use H plus or anything H2SO4 LAVH acid, I am using H plus here. You can use anything PP, PCl5, okay. So what happened? Here, then one electron connect with H plus, okay. And we will get okay. Then leaving group will remove, okay. So the anti position is phenyl, okay. So this group will migrate here. Remember one thing, if stereochemistry given, we should first give the priority to the stereochemistry, then migrate it, okay. If CH3 group will be here, okay. Suppose, so the CH3 group will migrate, okay. You should not consider the migratory aptitude. So here phenyl group, so we should migrate the phenyl group, okay. Okay, so the carbon will get positive charge because this bond will totally migrate to the nitrogen, okay, using the 2 electrons to that bond with the nitrogen, okay. So carbon will get positive charge, then work up with H2O, okay. I am giving you mechanism for some examples, okay, so you can understand easily. Then I will use the short trick how to get the product, okay. So we have nitrogen, okay. And what happened? This hydrogen remove in the form of H plus, and we will get catalyst. Okay, this is because it is catalyst, so giving the electron to the oxygen, and oxygen will neutralize. Okay. Here is enol form, so it tautomerized to the keto form. How? I have given you the mechanism in cyclic keto, like this bond, double bond, will migrate to the hydrogen, like the bond with the hydrogen, and this bond will come here, making the C double bond O. Okay, so we will get substituted amine. Okay, this is the product. Let's go to the second example. Okay, so the OH group will here, so its anti position is this. Okay, so if you use PCR or anything, okay, so I am giving a short trick. What happened? So the which group will migrate here? OH group will remove. Okay, so this group is anti to this. Okay, so this group will migrate to the nitrogen. So we should first write it like this. Okay, okay, migrating group should be right here. Okay, something. Okay, migrating group should be right with nitrogen, and with CO we should write CH3. Okay, on the remaining CH3, so the remaining CH3 group will attach with the CO group. Okay, we will get substituted amide. So this is the product. Let's go to the second example. Sorry, third. Okay. Similar. Okay, this group is phenyl aride. Okay, and this is alkyl here. So which group will migrate? Here we have given stereous chemistry, so this group will migrate. Okay, this is anti to the living group. Okay, if we have not given stereochemistry, chemistry, so migrating aptitude, according to the migrating aptitude, phenyl group will migrate. Okay, anything, okay, PP or anything you have given, polyphosphoric acid, we will get here OMe, NH, okay, then CO, then CH3. Okay, this is the product. Let's go to the fourth example. Fourth example is similar to this. Okay, you can understand and you can think that this is very simple, but we will learn very complex example. I will give you some complex examples in homework. Okay. So anti-position is this. This is the product. Okay. If I am writing this not I am giving stereochemistry, so this phenyl group will migrate and we will get same product. Okay. And if CH3 group will here, OH group will be here. Okay. So the end position will be CH3. So CH3 group will migrate to the nitrogen. That's I am solving so that you can understand. Okay.